Good afternoon, ladies and gentlemen. My name is Maximilian Gannes, and today I would like to welcome you to the ET7 Aerodynamics Workshop and the official CD value presentation. The ET7, as you see behind me, has achieved the very low value of 0.208, which represents a milestone both for the aerodynamics development within NIO cars and one of the lowest CD values worldwide currently available for a sedan of its category. The main contributions to this outstanding performance I will illustrate now. What I will illustrate now are 13 enablers that have contributed to this incredible aerodynamics drag performance target that we have achieved. The first set of enablers are located in the front of the car. First being the optimized front hood radii and angles, meaning the angle that the hood and the front bumper form with each other and the radii that they have achieved. Second being the same angles and radii that the front bumper to the headlamp and the side fender were able to achieve. Third being then the angles that the chin spoiler and the front bumper achieve with the underhood of the car to the skid plate. And then adding to that, we have an active grille shutter system that also improves the aerodynamic performance in total of the car. If we look at the single contributions, looking at the contribution of the hood, radius and angle, together with the radii of the side bumper to the headlamp, the total contribution is round about 5.6% to the total CD value that we have achieved. The AGS active grille shutter system contributes to about 8% of the total CD performance, whereas the chin spoiler, angle and radii to the underbody obtain overall contribution of about 1% of the CD value. I will now illustrate the rest of the enablers, moving down to the rest of the car. If we move to the side of the car, there are other enablers that also have contributed significantly to the lowering of the CD value. One of the main enablers that is most evident and that you can see here are the rims. For the ET7 we have a series of aero-optimized rims that contribute by themselves to lowering the CD value. In total, the most efficient aero rims that we have contribute to about 2% of the lowering of the aerodynamics drag coefficient. At the same time, we spend significant amount of time optimizing the rear view mirrors that you see here. They have a very optimized aerodynamic shape that not only lowers the aerodynamic resistance, but has also been optimized to lower the greenhouse wind noise, meaning the interior noise comfort level of the car, and at the same time they have been extensively optimized in order to improve their water management, soiling and vehicle contamination performance. I will highlight some of the features. You see here some of the water channels as well as the radii and form of the mirror that have an aerodynamic shape that is very efficient. We also have other features that are NIO proprietary that we cannot go into much detail in, but overall in total contribute to improving the water contamination performance of about 80% for this mirror. We also have a very optimized A-pillar configuration. The radius and flushness of the A-pillar to the windshield, as well as all the sections compared to how the A-pillar sits compared to the chrome, and gap and flushness to the rest of the parts, also improve in total and contribute about 1% to the lowering of the aerodynamic drag resistance. What is also very evident and significant on this car that many people can see and have started to discuss are the LiDAR and camera system that is located in the sensor bar on the roof of the car. These have constituted quite a challenge for the aerodynamic development work that we executed, but in the end, even though they are located right at the top of the car, which is generally a location that tends to deteriorate the aerodynamic performance, by doing extensive work in DOE, we were able to minimize the aero impact of these sensors and LiDAR on top of the car. I will now proceed to the rear of the car and illustrate other enablers that constitute and contribute towards the incredible aerodynamic performance that we have. I will now illustrate the aerodynamic enablers on the rear end of the car. As you can see, we have chosen a fastback configuration for the ET7 sedan. The shape of the rear tailgate combined with the shape of the ductless spoiler in total contributes to about 3% of the total aerodynamic performance. We spent a significant amount of time optimizing both the shape of the duct lip, the radius, and the angles from the duct lip, from the tailgate towards the rear end of the car. As you can see, some significant feature. The spoiler itself is not limited to the tailgate, but actually extends over into the rear tail lamps. This part, combined with this part, is very important for the overall functional and aerodynamic performance. At the same time, you can also see some other features, such as the C-line cut on the rear end of the car, that then allows the flow of the air to be separated and cut off in order to reduce the overall aerodynamic drag. This feature here is critically important for the overall performance of this car and is one of the main enablers that I will illustrate later. At the same time, what you can also see is that we have a particular configuration like an S shape on the rear diffuser. This, combined with the angle of the diffuser and the almost completely flat underbody shape configuration, overall contributes very significant to the total aerodynamic performance. This concludes my illustration of all the enablers that I will discuss.